Welcome to another 60 minutes of unscripted .NET entertainment. As doctors of .NET, we prescribe healthy choices in Wait a minute. So we're doctors in Who made us doctors? Did we go to .NET medical school?
No, yeah, we just gave ourselves those titles. Apparently, we're.
I printed mine online.
That's where I got Hi, everybody. Yeah, that guy. Yeah. Okay, so I'm your host, Cam Soper, with co-hosts David Pine and Myra Wenzel. And our guest this week is our sometimes co-host, but he is stepping into the role of panel guest this week, Luis Quintanilla. Luis, can you please tell our viewers a little bit about yourself?
Yeah, absolutely. So I am a content developer here at Microsoft. I work across a variety of products in the Docs team. I work on Azure Machine Learning and also on ML.NET and .NET for Apache Spark.
Cool. And also, you're also one of the coolest coworkers I've ever had. Just so we're clear. All right. So it's a new week. It's a new topic. We're talking about Fsharp this week. How about a checkup?
Let's do it.
Go ahead.
All right.
Oh, you know what? I did the screen sharing. There we go.
We're going to move you over here, and hopefully this is large enough for folks on stream to see. But the checkup doc today is in Microsoft Docs here, and it's under the Fsharp directory here. And it's a tour of Fsharp. Now, this is not completely comprehensive. I think I saw a comment there, Karun Agarwal, saying it's a stream good for beginners in Fsharp because he hasn't really coded or developed with Fsharp yet. And the answer to that is yes. And one really good place to start is in this checkup doc. It kind of takes you through some of the basics of the language, some of the syntax, and taking a step back a little bit as far as what is Fsharp. Fsharp is a functional first programming language for .NET. Now, it's not specifically tied to .NET, but typically that's in the how it's used, right? And in this checkup doc, again, you'll see some of the main things. Everything is pretty much about functions in Fsharp. You can take a look at how numbers and literals are represented. You can also take a look at some of the data structures you might be familiar if you developed with C#. All right, the tuple data structure. You can look at the list arrays and sequences. Something that I'm going to talk about a little bit here, and I'll explain it through the demos, is this concept of pipelines and composition, and how you can basically take the output from one operation and pipe it as the input for another operation. And you can just build these pipelines of different transformations on your data. And it's really easy to do with this pipe operator. Yep.
Kind of like PowerShell?
Very much like that, very much like the pipe operator in Bash, right? So it's a very similar concept. And again, it lends itself to a very concise and nice way of expressing these compositions of transformations.
Interesting. So you mentioned functional first. So I know that C# being one of the languages of .NET, so there's C#, there's Fsharp, and there's VB.NET. Out of curiosity, what makes it functional and how does it differ? I mean, can't C# also be functional?
Yeah, well, certainly you can do functional things with C#. It's not built from the ground up, and functions themselves. One of the things that makes it functional is the fact that functions are basically first-class citizens and are the core concept of the language. Everything is functions and expressions, and that's kind of what makes it functional. And the key point to stress there, that functional first, what that means is that it's not functional only. You don't have to do everything in a functional way. While it's sort of the prescribed way of doing things, you can certainly, because it works nicely with .NET and it's the functional first language for .NET, you can also use everything that you would otherwise in C#, and you can also use things like classes and use object-oriented concepts inside of a Fsharp code where they make sense, right? So it's not to say that just because you're going, there's a functional first language, that this is the only way of doing things. You can certainly also, where it makes sense, you can go ahead and use those object-oriented pieces of the language.
Interesting.
And we got a question here from Fawad saying, is it fair to say it's very similar to Kotlin, which is another functional language, right?
I'm not too familiar with Kotlin. I would say it's more along the lines of like OCaml. It's kind of like those ML type of languages, right? And yeah, Kotlin has a lot of so the way that I would also look at it, and like I said, I don't know too much about Kotlin, but from what I've seen, Kotlin has functional aspects to it, but it's not functional first, at least from my understanding, right? So there are some pieces that might be similar or some concepts that might be similar, but I don't think Kotlin is functional first. Yeah.
So let me ask you this, Luis. I know you have some. I know you have some things to show us in the hallway track. Does that include any like? This might be selfish of me to put you on the spot like this, but does that include any like Hello World like level apps? Because I've never touched Fsharp.
Yep, it does. And I'll be kind of showing those. I won't necessarily be showing. You can kind of look through the tour of Fsharp for folks on the stream if they want to learn more about this. But I'll be touching up on some concepts, and pretty much a lot of things that you're seeing in C# 9 now are actually they come from Fsharp. So it's things like record types, right? And pattern matching and concepts like that. I won't really cover them because folks who may be familiar with C# might already also be familiar with these concepts, and maybe the syntax may differ a little bit in Fsharp, but the concept is generally the same. But I will cover some sort of Hello World introductory stuff, and then I'll get into some sort of web apps and demo those.
Okay, cool.
Yep.
Well, let's get to it.
Awesome. Let's do it. All right. So let me make this a little bit bigger here. Awesome. Okay. Hopefully that's big enough for folks to see. So let's start from the foundations. And this here, what I'm using is Fsi or Fsharp Interactive. And one of the really nice things about the language that I like is the fact that you're able to just start writing code right away without, you don't have to start up a project. You can literally just, create a file, an FSX file, and you can begin just interpreting and running code basically interactively, right? That's the interactive portion of FSI.
So with FSX, is that the file extension that makes it interactive?
Correct. Yes.
Okay.
That's right. And if you recall, and I don't know if they're still around or still used in C#. I haven't seen them in a while, but this is very similar to those CSX type files, right?
Ah, yes. Okay.
Yep. So there's that X component there.
So what real quick from like a 30,000 foot view, what are we talking about? Like what Dave was just asking about? Because I had no idea.
Yeah, so CSX, and folks who might know this a little bit more, I didn't work too much with them, but essentially it's these files that are already sort of pre-compiled, I believe, for C# or whatever .NET language that you're using, and you're able to sort of run them like you would a script. So so essentially you're running it as if it was a script, and it's not dependent on, say, an CS proj or an FS proj type of project file in order to run. Yeah, so you can run them as standalone units of code.
Gotcha. Okay.
Thanks
for humoring me.
Yeah, and this is the same way. So I'll kind of show you this how this might work and how you might run a script. So here, I have just this one file, intro to FSX, and if I wanted to run it as a script, .NET FSI intro FSX, and what this is going to do is it's going to run all the code in here as a standalone unit, right? And then here I'm printing one, and then somewhere down here I'm printing other stuff like woof and meow, right? And I'll kind of get through the code here in a bit. But again,
could you zoom in just a little bit more?
Yep. There we go. Is that better?
Much better. Thank you so much.
Okay. Awesome. Yep. So that's the case where I wanted to run the entire script. So here, my logic isn't, there's not a ton of logic that you would see that's useful, but you can imagine writing a quick and dirty script, like a bash script or something like that, putting it into one of these FSX files and then running it, and it would just execute, right? You don't need to go and create a project. You do have to add if you have dependencies, you can add those, and I'll kind of get into that a little bit later. But if you have no dependencies, you can literally just get up and running with your base class library, right? And without a lot of ceremony. And that's one of the advantages of Fsharp is that you can get started really quickly. The language makes it really, really simple for you to get started running code. And in terms of syntax, it's very succinct, and it's very, you don't have to, one, it doesn't really have curly braces. There are some curly braces, some places where I'm going to show those later. But you can literally just start expressing, you can go from sort of, idea to code in a very easy and quick manner. So that's kind of F# Interactive, and basically you're able, you kind of have this way of running code as a script, right? And you're able to interact. Now, in this case, I'm just running code. This is no different than, say, doing .NET Run on a project, right? Where this really becomes really interesting is, and where the interactive component comes from, is that you have this sort of REPL, right? So the read, evaluate, print loop in F# as part of FSI, we're able to send not the entire script, right, to figure out, to see like, oh, well, somewhere in my script there was something that went wrong. You can run your code piece by piece and line by line, and you're able to evaluate it and see, okay, well, is my code doing what I intended to, right? So.
And one thing that Jaywood was bringing here about the extension, so you have Visual Studio Code, and then the .NET SDK, and then the Unite extension. Anything else that you're running, or?
That's it. So that's a really good point. Thanks, John, for bringing that up. So what I have here and you'll see some of the things that I do here. Ionide. Right. So all I have here is this Ionide F# extension, and Ionide provides a lot of really neat things, such as this thing here, which Ionide is open source, and it's developed by by folks in the community. One of the nice things that Ionide gives you is this thing. It's another package also working in tandem, but you're able to see here that it's telling you this is the type that this value contains, right? Without me telling it, hey, it's an int. And if you hover over it, it will also tell you that it's an integer, right?
Okay. So that //int is a GUI hint. That's a hint in your IDE.
Correct.
Here. That's not.
Yep. I did not have to express that. And in a similar way, if I were to say it, hello, you'll see that it changes to a string.
Oh, I thought that was a comment at first. That's cool.
Too.
Yeah. No, that's all. It's just helping you. And where this becomes really useful, and you're going to kind of see it later, is when you're building up those pipelines. It's really interesting because sometimes you'll get lost in a similar way when you're developing, let's say, link, right? Sometimes you'll have a series of transformations on your data, and somewhere along the line, halfway through, you'll forget, and you'll forget what type am I working with? What am I doing here? What's the transformation? So these annotations, I'll call them that. I'm sure they have a name, but I'll call them these annotations. They provide a really nice way for you to visualize what type of data you're working with. And speaking of types, you may notice that in this case, I didn't have to tell it that this is an integer. It inferred that it is an integer,
right.
which is another really nice feature. The type inference and the type system in F#. It's actually really nice. And again, it goes back to that idea of succinctness, and you're able to express yourself in a very succinct manner. And
that's just based on, like you said, inference. And it's like, it's looking at the literal assignment and saying this is a numeric literal, so it's an int.
Yep.
And
exactly.
It's very similar to like Python, right? It knows you don't ever have to specify the type because there's not really types, right? It's just this is the thing, and it's interesting.
Almost. Because in Python, well, now you have Python, you have type annotations, right? And you're starting to see that shift in these dynamic languages like Python, where and we can sort of get into that. So I've done my fair amount of Python because that's kind of like where a lot of the machine learning and data science tools live, right? And again, Python has that thing of it's very succinct. You can get started. The syntax is really simple. It's almost like it's almost like pseudocode, right? When you're writing and when you're reading it, it's almost like pseudocode. So it makes it really easy to reason about. But personally, one of my biggest gripes is that I love my types, and I'm lazy, and I am I'm not the best programmer. So I like having the compiler behind me the entire time. telling me like, hey, this won't run. And in this case, right, you get a little bit of both, where you don't have to express the types, but at the same time, you always have that compiler helping you the entire way. So you get the best of both worlds. And Kurt Mueller there, hot take: F# is a better Python. I wouldn't disagree. Yeah, if you like Python because of its succinctness and how easy it is to read, but at the same time you really like types, and this is not the only reason, but F# is a really, really good alternative for you.
Sorry, Myra and I are fighting over who displays Kurt's comment. It popped up and
that was funny, no.
Yeah,
just behind the scenes stuff.
Yeah, and our friend here, Sal C, isn't that an NDC video? And you are correct. So the program manager for F#, Philip Carter, he actually did a video at NDC. He did a presentation at NDC, and that's the name of it. It's F#. I think it's F# a better Python. If you look at it under that, and then sort of tag on NDC, you'll probably find it.
Yep. I have something that just came up in the chat. So our good friend here, Fuel Snable, points out that indention matters in F#. Tell me more about that.
Yep. So again, there are no curly braces. So because there are no curly braces, you need to have some way to reason about what the scope is and where does a certain expression start and where another ends. And in that sense, you'll kind of see a little bit later, and you may have seen it before. It's kind of white space delimited here, right? Where you just indent, and that's how you're able to tell it, hey, here's where that sort of next scope starts. Right?
And that's a really interesting thing too. So correct me if I'm wrong, but also the naming of files matter, because the order in which they're compiled has to be sequential. So that if you have a file that's named a.fs, and it's trying to rely on something from b.fs, it won't work because b.fs didn't compile first, right?
Yep, exactly. So it won't allow those sort of circular references, right? So which makes it really nice.
Or scary and terrifying, right? Like
it can, yeah, it can. It can, yeah. And there's definitely debate there as to what is that a good thing or is that a bad thing? Personally, I think, like most things, it depends. I think for the most part, it helps, right? Because it helps you reason about your code and okay, well, what are my dependencies, and kind of, I'm able to sort of build clean code, not because I want to, but kind of because I have to. And the way that F# compiles and it builds the code and interprets it, it's kind of forcing me to think about writing clean code, right? So that's one of the things that, while it's F# is fairly liberating in many respects, there's also some conventions that force you into writing good code. So and some of those you'll probably see later in some of these demos.
That's probably the better argument.
Our friend did make the comment that you're correct. The ordering matters, but that in a project the ordering doesn't matter.
It's not alphabetical. Maybe.
Oh, but in a project, B can be before. Yes, that is true. If I'm understanding, kind of like you mentioned, Myra, where it's not alphabetical ordering, or in the ordering that we're referring to is sort of in
within a single project, files within that. So if you have two files, a file a.fs that was trying to depend on a file named b.fs with under the same project, that order matters.
Yep, okay. Exactly. Yep. Right, exactly. Yeah, it's not so much like you said, not alphabetical, but it's more like, how do you structure your dependencies so that you don't get those circular dependencies like Gregor pointed out here in the chat.
Got it.
Yep.
Okay. So already we've scared away half of our audience that's not already die-hard F# developers. No.
Although we do seem to have a few people. Right. We do seem to have a few F# experts in our viewers, among our viewers today. So please keep the questions and comments coming.
Yeah, absolutely.
Yeah,
go ahead.
I was gonna say we love the engagement. This is awesome.
Yeah, that's one of the great things about the F# community. It's really great. I really enjoy the community. There's a lot of very talented, way more talented folks than myself. who could probably speak more to these topics, right? I came up here and sort of started talking about it mainly because there's been a lot of C# on the show, and I'm like, you know what, we need to balance it out a little bit. We gotta throw some F#. But yeah, there's certainly a lot of Go ahead.
I was just going to say, somewhere one of our viewers is sitting there pounding on his desk saying, "Yeah, but what about VB?"
Yeah, and I think there is a comment somewhere about VB by Peter Wright. Right? It looks like VB and C# had a baby. Yeah,
that is hysterical. Oh my gosh.
Maybe we need to bring Kathleen to balance it out and have VB.
Absolutely. Yeah, but no, that's, without a doubt, there's a lot of really talented folks in the community, as with a lot of communities, who can, if you're interested in any of these particular topics or learning more, they'd be happy. They're very open and willing to help others learn. Yeah. Okay. So with that, I was going to talk about, so initially I just did .NET FSI, Intro FSX, which ran the entire script. And that's great. But again, this is no different than doing .NET Run. Why would I want to do these interactive files or these script files, right? And one of the reasons as I was saying, is that you can run this code line by line, and I'll kind of show you how, right? So here I'm using Inide and some of the key bindings from Inide, and I'm just hitting Alt Enter. And what that's going to do is it's going to launch Fsharp Interactive, and it's going to send this code that I highlighted over to the REPL, right? So the read evaluate the value of print loop, right? So now let's get started. You can just tell it let x equals 1, and as you can see, it tells me that the value x is an integer and it's equal to 1. So I find it there. And if I want to print it, I just tell it print %i. In this case, I'm formatting it and telling it print an integer of the value containing x, and then it's just going to say 1. Right. So that's great. One of the things you'll notice here, it's this let. If you've done some JavaScript, this let keyword, that's how you assign values to a variable.
Let me back up and make sure I understand what I just saw went on here with the REPL. Mm-hmm. So you selected open system and OpenSystem.io, and you ran those two lines, right? Mm-hmm. And then you ran the let x equals 1 line, and then you ran the print function %i line, right? Mm-hmm. And that's those are all within the context of this instance of the REPL.
Correct. Yep. So now if I wanted to tell it something else, print fn this is another way to print %i. There. So it remembers, that context of what x is, and then I can just use it in my REPL. So I don't even need to include it in my script. I can just continue, plugging away at things and trying different things in the REPL without having to do it in the script here.
And that context is persistent. So rather than it being like a fire once and kind of forget, mm-hmm. that state is truly interactive here, such that it's persisting that x is a variable declared within this scope, and you can continue to build upon this little experience. That's really interesting. Yep. Well, I was going to ask one syntactic thing real quick. Mm-hmm. You do double semicolon within mm-hmm. the terminal window there. Why is that?
Yeah, so that's how you tell it that this particular expression ends. So it's just a way to tell it that's the end of my code. So what you can do is, I don't even know if this will work, but print the fan.
So it's not just 1.
It's not 1, it's 2. So %i.
Is that because F# is twice as good as C#?
Yes, exactly. I think that's the reason. I think you solved it. That's why. That should be the official reason why.
Okay, cool. No, that makes sense.
Yeah.
So this whole experience, the read evaluate loop reminds me so much of the PowerShell ISE. Right. I mean, already the language kind of reminds me of PowerShell, and like the way this extension works in Visual Studio Code reminds me of the PowerShell ISE. I feel like PowerShell folks might be pretty comfortable in this.
Yeah, absolutely. And to even extend that, right? Like I think a lot of folks, especially if you're new to programming, getting into programming, there's definitely some concepts and you can get really really complex with F#, as with most languages, right? Like you can get into some pretty complex topics, but getting started, right? Like, you know, if you were to tell somebody, hey, you know, write some code to print out a value, right? This is all you need, right? So these 4 lines, and not even the system.io, right? So you just need the system. Actually, I don't know if you even need system, but anyway. So this is all you need, and somebody could kind of reason about it. Say, okay, I see that, you know, and they explain to you, well, you assign the value and you store it here, and then you just print it out. Like that's pretty, you know, fairly simple to reason about. Instead of telling them, well, you got to get, you know, well, aside from the setup, right? But you have to, you know, run, you know, get .NET, and then you have to .NET new and do all these things just to do this, right? Folks might be deterred or maybe discouraged from even getting started. Right.
So I wanted to ask another kind of naive question, because I haven't messed around too much, admittedly, with F# myself. So one of the things I look at whenever I'm trying to like solve some sort of problem with software, I usually just default to things that I'm comfortable with, unless I'm trying to force myself to learn something new. What are some of the best ways? Oh, my video is going.
Yeah, we lost we lost your green screen.
Yeah, errors occurring. That's cool. I was going to ask though, like, what would you do if you were to, like, I want to know how I can take F# and actually apply it to real world problems. Like, you know, can I build websites with it? Can I build like interactive UIs with it? Like, or is it just for like typically scripting? Like you mentioned, you know, PowerShell and stuff like that. Like, what's its core usage?
Well, the great thing about F# is that because it works with a lot of the .NET libraries, you can basically do anything that .NET does. So whether that's web applications, whether that's Xamarin applications, right? So if you're building mobile apps, you can build mobile apps using F#. In the web context, you know, I didn't include in my resources, which I'll show later, but if you're trying to get on WebAssembly and WASM, you can try out this library called Bolero, and you can do WebAssembly and build WebAssembly applications. So web apps that use WebAssembly using Bolero, right? And F# for that matter. You can do statistical and you know, basically machine learning with F#. So basically anything that you can do with .NET, you can do it with F#. And there are some abstractions, which I'll talk about later. There are some libraries that make it easier, because just because it works with .NET doesn't mean that it's syntactically, it's very, it's compatible with the F# way of doing things, right? So
we had a question come up, and I was about to ask the same thing. So if I just heard you right, you said we can write Blazor applications with F#, right?
Correct. Yep. And the name of that library is Bolero. And you can take a look at that.
So not everything comes like out of the box. Like for example, for Blazor with F#, you need to use an external library. But in some cases, like console applications, you have the template built into the SDK to do F# applications.
Yep, that is correct. Yes, that is correct. And a lot of times, the reason for these libraries, it's not so much that you can't do this stuff with F#. If you were to just pick up a library or grab a dependency on ASP.NET, right? It's not so much that you can't just write F# code to use that. It's just that it's not the F# way of doing things. So the way that so people build these libraries. So for example, going back to that scenario of let's say that you want to build an ASP.NET application. Well, you need some sort of like startup file, and then you have your program.cs, and you can write it in an imperative way, in a very C# like way, and it will work, right? It will work. But again, that's very the C# way of doing things. But for folks who prefer more the simpler and less ceremonious way of doing things in F#, there's folks who build these libraries on top of things like ASP.NET. So one library that you might want to look at is Giraffe, right? So Giraffe is built on top of ASP.NET. And it provides a bit of more of a F# way of doing things. And I can show some demos here of this other library that's built on top of Giraffe. So there's even more abstractions on top of these other libraries that make it really quick and really easy to build applications. And you know, the library that I'm talking about is Saturn, right? So Saturn is built on top of Giraffe, and it provides this really nice, almost like a domain-specific language for building these web apps that make it really, again, low ceremony and very easy to get started.
Awesome.
Yep. All right. Let's see here. So I'll, just kind of run through these real quick. One of the cool things is, here you can just basically define functions. So again, in this case, we're using the same let keyword. We're telling it the name of our function here is double, and it's going to take in one parameter. And then we're just going to multiply that, what we're passing in, by 2. And then
so double is the name of the function, n is the parameter, and the function is equal to the expression of n times 2.
Correct. Yes. And you'll notice here now in the marker, what you get is int arrow int. What this means is it takes an integer and then it returns an integer, right? And that's what this is telling you here in this annotation.
But to change that, you could simply say, n times 2, but use that string formatting bit so that it takes an integer but returns a string doubled.
Yep.
Okay, so and I hate to be pedantic and slow down your presentation, but this is mind blowing to me. This is a function declaration in one line, like we would do like a lambda in C#, right?
Yep.
Or even a local function, which is better in C# now, but still a lot more verbose and ceremonial than this.
Yep, exactly. Yeah. And maybe somebody coming in reading it, it's like maybe they don't have these annotations. So it doesn't make sense. And if you want to be very strict, especially when you're building with custom types, you also have the option of being a little bit more verbose. So in this case, if I wanted to tell it this is going to be a float, I can do that, right? And notice how now it's complaining. And the reason why it's complaining is because now the 2 is not a float. So to fix that, there's that. And here it's going to complain as well because, again, it's not a float. But then I do that, and now we're good to go. It compiles, and now I'm able to run this code.
Wait, so zero's inferred? You don't have to do like .0? I'm so used to just doing
yeah.
dot.
Yeah, you can just put that dot at the end, it will sort of convert it to a float. So that's how you can be a little bit more verbose. But again, for readability purposes, let's assume that you didn't have these annotations. If you were to just read this, you would say, what is n? I don't know, right? So if you want to be a little bit more explicit and a little bit more expressive and make it easy for folks to read, and especially with custom types, this is useful, right? Because sometimes, like, the type inference will only go so far. Sometimes if you have types that have similar sort of signatures and things like that, it might get a little bit confused. So in those situations, you have to be, you have to actually explicitly tell it, this is the type that's going in, or this is the type that's coming out. So essentially we do that, and then when we run it, it's what's expected. So 2 times 3 is equal to 6, right? So pretty straightforward there. The other cool thing about Fsharp, again, because everything is functions, is that you're able to return a function so you're able to not only pass in functions as parameters, but you're also able to return functions, right? So in this case, what I'm going to tell it is, I want you to make a sound. We're going to pass in an animal, and then we're going to run this function that's going to take another parameter called output, and then it's going to say the animal says whatever you told it to say. But instead of returning the value, we're returning the function call so that we can then apply it later on and do partial application. So to kind of make it concrete. Wait. Yep, go ahead.
I'm mind blown here.
I was going to say, did we just make a see and say in Fsharp?
A what?
A see and say, that those toys that you for little kids with the little spinner, and you pull the thing.
That's exactly
the dog says.
Exactly. That's what we did.
So wait a second. Let me wrap my head around this real quick. So let make sound given an animal is equal to let call output. Output is still a parameter that we'll call into because we're applying it from the outer function. Print function, and then it's just doing the print stuff on animal and
output. Yep.
Output, and then it's returning call, which is the function the declaration itself. And then you can say let make sound dog. So wait. Then you call make dog sound there on line 21 later on.
Yep. So here's where I defined the function, right?
Yeah.
And then here I can store the value of make sound in another variable, variable. Exactly. So here I'm going to tell it make dog sound, and then you can call. Yep. And you'll notice that the type here. So now what this means is I'm going to pass in a string, and I'm going to return to you when it's in parentheses like this. It means I'm going to return to you a function, another function that takes in another string, and unit in this case is basically like void, right? So when you print, console.writeLine, it's void, all right? So unit in this case, it's like void. And so now that I've stored this here, make dog sound, now I can call it make dog sound, and I can tell it woof, make cat sound, meow, and now it actually executes this inner call function, right?
Oh my gosh. So hypothetically, you could call make sound dog wolf by itself, just as a standalone, right? Make sound, because that's just stored functionality that you have there before. So I'm not even make dog sound. Just do make sound dog wolf, because you got make dog.
Make wolf sound.
Yeah, so just do no. I'm sorry. So say, I want you to call make sound, give it dog, and say meow. So it's a dog saying meow. I mean, just to show that you can still just call that original make sound function from above, given those two parameters.
Yeah. So make dog
sound.
Make sound dog meow. There it is. So the dog says meow. Yep.
Right.
So in this case, we partially applied it where we stored the value of the function, this inner function, into a named variable.
So it's partially applied. So
it's partially applied.
Oh my God, this is insane. You can't do this with C#.
Yep.
So you keep saying you stored the value. Now is that, am I to take that literally, or are we storing values here, or are we storing references to functions?
Both. In this case, you are storing the reference to this function here, and let's say somewhere down the line. Well, actually, in this we couldn't store this one because it's a void, right? So we couldn't store the output of this inner function. But if you did have something that returns here, you could store that as well, and then you can store the value. But in this case, you can just you're storing the value of a function. That's Fuel Snabel makes a really good point that this could actually be rewritten. Here in this case, I went to showcase how you might do partial application. But what you can actually do in this case is this, right? So this is kind of what Fuel Snabel is referring to, right? So make sound, and then
oh my gosh,
what we're doing here, make dog sound, and again we get that same thing here, right? String unit, and then when we do that, dog says woof. So you could do this in, I made it 2 lines here, but you can literally do it in 1 line. You get the same effect here. And what you notice here is we just rewrote everything sort of live, and got it all type checked. And yeah, so it's super easy when you're doing this interactively. It makes it super easy to A, edit your code on the fly, and B, make sure that it's doing what you expect it to do.
I am trying to rewrite this right now in SharpLab.io in C# because I'm very intrigued by this.
Yeah. So that's kind of how you would kind of go about doing partial application in this case. And one of the things that you'll notice here with these, so in this case, if there's the gang of 4, and in object oriented there's all these patterns and stuff like that. So in this case, you could kind of use something like this to for example, if you had like the strategy pattern, right? Like you wanted, like there's this thing that's kind of generic across all things. For example, if you want to make a bird fly, right? But maybe what's it called? A wooden duck would not fly, so it has to have its separate implementation. And maybe a chicken would not fly, or whatever it is, right? In this case, you're just writing functions, yet you're able to apply these these patterns from the Gang of Four. But at the end of the day, you're not being very ceremonious about it, and you're not necessarily calling it that. It's a function at the end of the day, right? Cool. So let's see here. So we have collections here. One of the really nice things that I like is collections. It's super succinct to build a collection. In this case, we're making a list from 1 to 10. And in this case, same thing. We're doing it, but with sequences. A sequence, you can think of it as like an enumerable. So the implementations differ. A list in Fsharp, my understanding is that it's like a linked list. And in a sequence is similar to an enumerable. And let's go about like what you can do and kind of that pipe syntax. So in this case, what we're doing here is we're taking a sequence of numbers from 1 to 10. We're mapping it. So sequence.map applies the function that you tell it to each of the elements in your collection. And then by piping, what we're doing is we're taking this as our input and we're passing it in to the sequence.map. And then we're piping that output again. So the doubled, sorry, it keeps popping up. So now we're piping the output from this into as the input of this next operation or transformation, and we're then producing an output. So in this case, what we're going to be doing is we're going to double the number and then square it. Right, so that's what this is doing in sequence.map. We're using this sort of anonymous function, and we're telling it take x, which is going to be each of the elements in the sequence, and multiply it by 2. And then do the same thing, each of the elements, convert it to a float, and then square it. In this case, you need to convert it to a float because this operator only works on floats. The other thing that you're seeing here, right, is what I was alluding to earlier, where with these annotations, you're able to see, okay, so this sequence of integers, here I'm still working with a sequence in integers, but in this case, now I'm working with a sequence of floats. And you're able to see the transformations throughout your entire pipeline.
So the double star operator is an exponent?
Yep, that's what it is. Yep. So if we were to go about it, there it is, right? So if we were to look at 1 times 2 is 2, and you square it's 4, 16, 3 is 36, and so on, right?
And the sequence map is to go through all the elements in the collection?
Yep, that's one of the really cool things about Fsharp is that it has a lot of built-in collection functions, right? So sequence map is probably one of the more commonly used ones, but there's tons of them, and I would encourage folks to take a look at the different sort of functions that are built in to the different collections of Fsharp.
Yeah, see, typically for like an iterator, I would expect to see like a for or a for each. But this is
yep,
this is elegant.
And you certainly could do that. You could still do for loops, but again, it goes back to that conciseness and readability and all that. I don't know if performance is a factor there, but it's possible that performance might also come into play.
I'm reading some of the chat stuff here going on, and there's lots of stuff coming through. People are talking about partial application equals higher order functions, and then I started thinking, oh my gosh, we promised not to talk about monads, and there's lots of weird nomenclature, not weird, just things that I always seem to forget, those definitions.
Yeah. Absolutely. Yeah. And so I'll try to get to those in a little bit. I know we're kind of running, we already have like 15 minutes left. So in this case, I just did these anonymous functions, if you will, lambdas, whatever you want to call them. But I can also write these as functions themselves, and then I can just tell it sequence.map triple. In this case, I'm just tripling it and square it, and same thing. Now, where it becomes super cool is notice how here there's all these squiggly blue lines, and what it's telling me is, hey, you could simplify this. You can basically take two functions, as long as they the parameters and the types and things line up. basically like compose them into a single function. And the way that you can do that is with this operator here, right?
Shut up.
Yeah. So now I'm telling it a sequence map and compose this function into a single function called triple and square. So instead of doing the pipe operator, we're using this operator here, and then we're applying in one line, we're applying both functions to this collection here.
Do you know how hard it is to do this with expression-based members, and composing things? Like, I've done this in C#, and it is extremely, so much more verbose. And this is insane. That's insane.
Exactly.
I love that.
And if you wanted to, like, maybe this doesn't make sense, right? So then you can just store this composition into a value itself, triple and square, and then you can just call it triple and square, and you're there. Going back to these the different operations, right? There's this other sum by, which is just going to apply, basically sum up all the values. So here we're going to triple and square it, and then we're going to take the sum of the result of this collection, right? So you're going to see here, if you were to run this, whoops, I haven't run this. What's going on here? Oh, sorry.
We do have a comment here. As you're typing that up, I'm going to throw it on here. Bob is saying that Link does a lot of this already. For C#, not the composition, not at all. I mean, not. There's no composition operator. There are multiple things that you can do in Link that will allow you to chain those types of things together, but not as terse as this.
Absolutely. And you're right. Yeah. So if you're familiar with Link, it's going to feel very familiar to you. This piping and the transformations and applying functions, so on and so forth. It's going to feel very familiar, right? I believe the mechanics are different, but conceptually you can think of it as being very similar. So that's kind of like some interesting things that are happening there. Let me see if I can get it. So one of the really interesting features of the language is this thing known as type providers. And I think the guest next week is going to talk a little bit about source generators in C#, which I believe were inspired by type providers, the implementations and some of the ways that they work are a little bit different. But essentially what they're doing, these type providers are building types for you on the fly without you having to express types yourself. So what do I mean by that? In this case, I'm using this library called Fsharp data, right? So this is another script, by the way. And what I'm going to do is I'm basically going to take a look at these capsules here from the API, right? SpaceX API, and you're going to see there's a whole bunch of stuff here. Some of the things that I'm interested in is the type of capsule. And the status, whether it's retired or whether it's selective. I want to take a look at which capsules from SpaceX are still active. Okay. Now, how I will go about it without type providers is I would maybe write a function to get my data, use HTTP client. In this case, you may notice that there are curly braces, and the reason for that is these are computation expressions, and so this is the way that you would. Basically write asynchronous code in Fsharp. And the curly braces here typically tend to they signify computation expressions. I said I wasn't going to mention monads, but to a certain extent, in certain cases, these can be like monads, right? Where they apply the different computations on the data that you give it inside of it.
So one thing I noticed, and I wanted to call attention to this real quick, since it is .NET, we are actually opening. So it says open system.net.http, and I can only assume that's very similar to like an import or like a using.
It's using. Yep, that's your using statement. So instead of using, it's open.
And then you say on line 15, use client. Since that's an implementation of iDisposable, you're saying you're going to dispose of it outside of that context. Then is that
correct? Yep, that's right. And you'll notice that. Now we're using let bang or let exclamation point. And the reason for that is this is an asynchronous call. The let bang basically unwraps and extracts the actual value. So you'll notice here that the type is data string. If I were to remove that,
it becomes the task.
Now you have async string.
Right. Oh my God.
Yep.
I am starting to love Fsharp.
So
I'm just happy I'm gonna understand Philip's PRs now.
Yeah. So here we actually told it, here's the type that we want. We want a type and we want a status, right?
Wait, pop quiz or
yes.
question. What is that backtick? Line 21.
Yeah. Okay, so this is another really neat thing. So as you may notice, type is a reserved keyword in Fsharp. But we have this property called type. By doing backward tick, we're able to tell it, hey, I really want this to be the name, and treat it differently than the reserved keyword. So you're still able to use reserved keywords in your properties or whatever, or even your functions.
And you could do that in C# with variable names, but you'd have to actually start it with like the @.
Mm-hmm.
I mean, that was one of the conventions. You start with like that @
right.
symbol. Interesting. Okay.
So in this case, I gave it the type, and then we just kind of go here and we tell it, hey, get our data, pass it in the string here, run synchronously. So in Fsharp, you have to start the async computation. You can't, it just doesn't start automatically. So you have to run it yourself. So that's why you have this async run synchronously. We use the system text JSON to deserialize it into a sequence of capsules. Then we filter because we only want to know what the active ones are, and then we want to get the distinct names.
Did you say Newton? You're not using Newtonsoft. That's actually the.
Oh, it's just the system text JSON.
Yeah. Okay.
So when we run that,
capsules.
That's fine. All right, so let's just run this, and then let's run this. Cool. All right, so
ta-da! Did we clap? Like, because all your demos are working and like.
Not yet.
Wait for it.
There we go. Okay, so now you can see Dragon 1.1 and Dragon 2.0 are the only active capsules that SpaceX has. Okay. How would we do this with type providers? So that's where Fsharp data comes in. First, you tell it a type, and you tell it JSON. In this case, we're using the JSON provider. There's type providers for many different types of data, like CSVs, HTML, so on and so forth. And we notice that here we pass the capsules endpoint, which is basically this link. So you're able to pass it either literal examples, files that you have stored. Basically, what this is going to do is it's going to tell it, here's the schema of my data. Learn that schema. And that's what this capsules type. Now, when we actually want to get the data, so this is just defining the schema. Then we want to store the data. We tell it capsules load, and we tell it again, load from this endpoint, right? So in this case, you define the type, if you will. And here you're actually calling something that is going to give you data of that type, right? So in this case, capsules.
So with that little dot root and the array on line 37 at the end there, the thing I thought was a comment, is that the type inference? It's looking at that and saying, the JSON provider of ... dot root as an array?
Yep, it's an array, exactly, yep. And there's the array right there. So now we can do the exact same thing. And again, remember that in this case, I haven't told it what the type is. I just told it, here's some data, learn this, the schema, and then do stuff with it. And then when we run this, you get the exact same thing. So the type provider is basically building types for you without you specifying the types, right? And
that's how everything should be. That'd be great if we could do that with like, I know that you can actually, so like with .NET, a lot of times what I'll do is I'll look at an endpoint that returns JSON. I'll copy some of the JSON example. And then from Visual Studio, they have that paste as C# classes functionality. That's awesome and not really well known.
Yep.
And that does like the same type of thing here, but instead of you having to type it, you just pass it the endpoint, which would be so much easier.
Yeah, absolutely. Yeah. And is this the way of, doing things? In some cases it might, right? Like maybe you need to get some data, you need to get some statistics off some website, scrape a website, if you will. But, you don't want to write the code to basically learn, you don't want to write the types and stuff like that. Maybe you don't even know what the types are. You can just point it to this, public endpoint, and it's going to basically generate these types for you and fuel Snabel I mentioned that source generators enable this in C# too. Yeah, and we'll have some, I guess, next week actually, which is convenient. Talk about source generators.
And folks are commenting that those double backticks can also be used for method names and variable names with
Yeah.
spaces.
Oh my god!
For test methods, it's awesome. I thought about adding test to this, but I didn't. But yes, you are correct. You can name your test in a way that is very readable. Not underscore, and fine, you can add underscores or whatever your naming convention for tests are. But in this case, you can make it much more readable. Yeah. So let's see. Should I go into the other one? Maybe. Okay, I'll do this one because we are running low on time. So in this case, I have this web API that I built using Saturn, which is built on top of Giraffe. And this web API does two things. You have this thing with this function here, which gets the values, and it just returns an array of numbers. And then you have this other one, which you can call, get value by ID. You pass it in an ID, and it's going to try to find it in the list of values and return it to you. One of the things you'll notice here is this, there's this pattern matching, right? So if you're familiar with pattern matching in C#, this should look very, very similar to you.
Now, is that that's the action method, right? That's what we would call an action method in a controller in C#?
Yep. Yeah, basically. Yep, exactly. And then you'll notice this sum and none. There in Fsharp, there are no null values, or or by default, it's either you have something or you have nothing. This is the option type. And this makes it really nice because you can't have especially with pattern matching, because pattern matching is sort of like it exhaustively search for the different patterns. You can't have unrepresented states, right? Which forces you into having to write an account for those edge cases, right? Which is one of the many reasons why sometimes you hear people say, like, if it compiles in Fsharp, then chances are that it's going to run, and it's going to run correctly. But anyway, here you have this handler, and these are both handlers, by the way. There's just different ways of doing it. You can either just do it as a function, or you can explicitly write a handler. And in this case, I'm just returning a text value with the value of the ID if it found it, right? Otherwise, return -1. Here again, you have these computation expressions, right? In this case, they built, the authors of the library built this sort of domain-specific language, this DSL, for writing web applications. And in this case, I'm basically creating a router and wrapping it inside of these curly braces. And I'm telling it, I want you to create a get endpoint. This is similar to endpoint routing, right? If you're familiar with endpoint routing style of doing things. And then you tell it API values, and then you're going to call get values, pipe it, and return it as JSON, right? And maybe this seems a little bit verbose, so you want to handle everything in the handler. And the way that you would do that is, again, you would create the handler, and then you just give it the handler. And in this case, we're using a formatted get endpoint, where %i is that parameter that we're passing in as an ID, right? And then sorry, go ahead.
No, I was just going to say, so, and then at the end, we spin up the application, and I mean, basically does the same kind of bootstrap as like startup.cs does on a web API, right?
Yep, check it out. Look at that. It's extensions hosting iHost Builder.
Oh my god.
Yep.
Oh, that's crazy.
Oh.
Yep. So with our limited amount of time, Luis, I want to pose a question to you. Because I saw a lot of people in the audience asking, okay, well, what kind of application is Fsharp good for? And I of course, have asked the same question. And I'm going to turn that question on its head just a little bit. For you specifically, can you tell me a question? Can you tell me a project, something that you've done that you chose Fsharp and you ended up being really glad you did, compared to, well, I couldn't have done this in C#?
That's interesting. So I've never really thought of it that way. I think I just naturally gravitate towards Fsharp because it makes, number one, I'm lazy and I want to write less code. I want to write as little code as possible, and I want to be able to express, do things quickly. They may not be the most, robust or, technically correct, right? But it will work and it will run. And, you know, having the compiler and again, the type inference and how succinct Fsharp is makes those things really come together nicely, where I know my code is going to do what I expect it to do, but at the same time, I don't have to write a lot of code to do that. And yeah, maybe it's not, you know, the prettiest code, but it's going to do what I want it to do. So that's typically how I look at it. I mean, personally, if there's a lot of, you know, quick and dirty scripts that I want to do, Fsharp is my go-to. And for projects, you know, I'll try my best to use Fsharp.
Well, I was gonna say, I think that's some very beautiful code. You said it's not the prettiest code ever. Fsharp looks very elegant. I'm thoroughly impressed. I thank you for being a guest today, and tune in next week, folks. We're gonna have Jason Bach on to talk about C#. What is it? Compiler or generated C#? It's
right
source
on a special day.
Fun stuff. Yeah, special day on Tuesday.
So, yep. So with that, thank you again, Luis, and thank you all of our viewers, and we will see you next Tuesday.
Awesome.
Take care,
folks.